Now let me explain you mole concept in solutions. Here it's written on the board that molarity is equal to mole of solute upon volume of solution. It's mentioned that solute is, let us suppose it is B and solvent is A. When they are combined, you will give rise to solution. Now what is molarity? Molarity is defined as number of moles of solute present in 1 liter or decimeter cube of the solution, and it is equal to moles of solute upon volume of solution in liters, and the formula will be W2 by M2 into 1 upon V, or you can write W2 by M2 into 1000 by V if you will take in ml. Now molality. Molality is defined as number of moles of solute dissolved in 1 kilogram of the solvent or 1000 gram of the solvent, and it is represented by small m. Here the formula will be W2 upon M2, that is molecular mass of solute, multiplied by W1 in kg, that is solvent ka mass. Now molality changes with change in temperature, will be change in volume, but molality does not changes because there is no volume in molality. You know the formula of molarity is W2 by M2 into 1000 by V, whereas formula of molality is W2 by M2 into 1000 by W1. So if volume is not there, so molality will not change with change in temperature. Now come to this formula of molality in the elaboration form. I have elaborated this formula. W2, that is given mass of the solute, upon M2, that is molecular mass of the solute, multiplied by 1000 upon W1, that is given mass of the solvent. Now let's compare molarity and molality side by side. In molarity formula, liters of the solution or volume of the solution is given, whereas in molality formula, mass of solvent, that is W1 in kg, is given. So moles of solute is similar in both the sections, in both the areas. Now let's start your comparison for them. Molarity is moles per liter, that is symbolized as capital M, whereas molality is symbolized as small m. Molarity is not constant, means it changes with change in temperature, because density or volume both changes with change in temperature. Here is one more difference between this slot has provided to you. You can go through this difference between also. Here also especially focus on the temperature and symbols, units, also definition you have already done in so many slides, but please go through the temperature, that molarity depends upon temperature, but molality does not depends upon temperature. Okay. Now comes normality. Normality is 1 gram equivalent of solute dissolved in 1000 ml or 1 liter of solution. Here equivalent is there, equivalent word is there. That is equivalent, gram equivalent you can also write as mass of solute in grams upon equivalent mass of solute or equivalent weight of solute. We can explain in more easier form. Here I have written normality is equal to number of gram equivalents of solute. Again I am repeating this thing. Number of gram equivalent I have written separately, that it is given mass upon equivalent mass, and equivalent mass is equal to molecular mass upon acidity, basicity or valency, or I can say it as n factor. And if I will put all these things in the formula, then I will get the relationship between normality and molarity, that is normality is equal to molarity into n factor, and n factor can be acidity, basicity, anything. Basicity you can consider for acids, means for example H2SO4. So H2SO4 is having 2 basicity, so you can use 2 in the form of that, instead of that formula you can put that value. Now here this is molality and mole fraction comparison. Molality, now you know the formula. Mole fraction, here solute and solvent is given, that is number of moles of solute upon total number of moles in solution. Here percentage concentration I have given you formulas. W by V, W means mass by mass, and V by V means volume by volume. So you can go through these formulas. Now let's come to the terms, small terms. If in numerical 1 molal is given to you, what does this mean? This means 1 mole of solute present in 1 kg of water. Here we have calculated 55.55 moles for water, that is 1000 by 18. So how you can calculate the solute mole fraction? This is given to you. Now come to this numerical also. Find out the molarity of 1 ml of water. So at 25 degrees Celsius. Here also in molarity I have written number of moles 1 upon 18. 18 is your molecular mass of your water, and 1000. So you will after calculating you will get 55.55. You have to mug up this particular value, because again and again in several numericals you will put this common value. Look over this numerical also. Go through it thoroughly. Here molality and mole fraction has been calculated. Moles of urea upon total number of moles they have taken for mole fraction. So number of moles is W2 by M2. You know the formula. So number of moles of solute or number of moles of solvent, दोनों का निकाला गया है. Look over this numerical, molarity and normality. Here 0.5 gram means W2 is given, V volume is given. After calculating molarity, you can directly calculate normality by using that relationship. Normality is equal to molarity into n factor. So here NaOH, how many OH are present here? Only 1. So you will get the same answer, that is normality is equal to molarity into 1. Fine. Look over this numerical, it's also given in your book solved. I have just sent this formula because this is important. First of all, you have to calculate the molarity. Then in the second part, after calculating molarity from in first part, you will compare by writing the formula M1 V1 is equal to M2 V2. This is called normality equation.